Assalamualaikum. Good afternoon, everyone. Is it audible? My sound is clear to everyone? Okay, first we'll do questions related to the thermometer as we discussed last week. And at the last, I will explain a thermocouple. So in this question, a 240 volt and a 60 watt lamp is connected to a 240 volt supply. The lamp has a constant temperature. State the rate at which the lamp transfer energy to the surrounding. Basically, rate of energy transfer means power. So what is the power in this question? What's the power given in this question? So power is 60 here. So what is the answer? Simply you will write 60. So power is 60. So simply you will write 60 watts. Because the rate of energy transfer means power. Because energy divided by time, that we call power. And according to the units, 60 watt is the power of the lamp. So it will transfer 60 joules. Because the meaning of 60 watt, it means it will transfer 60 joules in 1 second. In the next part, name of a thermal process from which a lamp transfer energy to the surrounding. Like you have a lamp here, a bulb or a lamp. Which process the lamp is transferring energy to the surrounding? Radiation. But if you read the question, they mention names of thermal processes. So it means it should be plural. Like we have to write two. So one is convection. How convection? Because the surrounding air will become hot, and that hot air will rise. So that is one is convection, and the other one is radiation. If it was only name, then I will write mention only one, and that radiation is the best answer in that case. Figure 4.1 shows a thick copper Figure 4.1 shows a thick copper block that has been heated around 400 degrees centigrade. One of the side of the block is dull black, and the other side is polished and shiny. In an experiment, in experiment 1, a thermometer bulb, both are painted black. You can see thermometer bulbs are both painted black. They are equally placed equal distance from the surface. The maximum temperature shown by each thermometer is recorded. Explain any difference between the maximum temperature shown by the two thermometers. What will be the difference in the maximum temperature which we read from these thermometers? Yeah, thermometer A, higher temperature than thermometer B. And what is the reason for that? A temperature will be higher than B. That's 1 mark. But because it's of 3 marks, you have to explain. Black is a, but in this case, emitter, you should use the term emitter. Why? Because the thermometer are recording radiation from a hot object. Yes, and how the energy transfer by radiation. So you will mention thermometer A. Thermometer A will record a higher temperature. The second mark is because dull and dark surfaces are good absorber and emitter of radiation. So how you scored the third mark, or what is the third mark here? Actually mentioning their good absorber of radiation. So this radiation will give you 1 mark, absorber and emitter give you the second mark, and A record a higher temperature will give you the third mark. In the next question, in the next part, in experiment 2, the thermometer bulb, both are shiny silvered color, like what we did. The two thermometer bulbs, not the surface. Now the bulbs are shiny and silver. They are placed at the same distance. State and explain any difference that is observed in the maximum temperature shown by the thermometer in experiment 1 and 2. Yeah, what will be the difference if you are using a shiny bulb? Means the bulb is shiny as compared to dull or dark surface for a bulb. Yeah, it will. You will compare when you will mention shiny surfaces are good reflector. So the reading will be lower. You can mention, or it will rise slowly. Yeah, that's right. In experiment 1, the maximum temperature is higher due to dull and dark, but in experiment 2, it's a shiny surface which is a good reflector. So the reading of a temperature will be lower, or as you mentioned, the ratio will be same but less temperature. That's also correct. So shiny surface is a good reflector. So small rise in or change in, or temperature, slow change in temperature. Yes, you can mention about absorber and emitter as well. Figure 4.2 shows a firefighter wearing a shiny silver colored clothing. State a benefit to the firefighter wearing a shiny silver colored clothing. What's the benefit here? For the firefighter having a shiny silver colored clothing. Yeah, reduced heat transfer by radiation, that's correct. Will absorb less heat. White color effects, color reflects or shiny surface will reflect more energy or heat. So small change in temperature will occur for a firefighter body. That's correct. So the answer here, you'll mention the firefighter does not get too hot or burned from the radiation because shiny surfaces are good reflector. State and explain any effect on sensitivity of a liquid in a glass thermometer. State and explain any effect on a sensitivity of a liquid in a glass thermometer. Reducing a diameter of the capillary. If I use a thinner capillary, it will increase its sensitivity or decrease its sensitivity. So it will increase the sensitivity or more sensitive. And how it will be more sensitive? Because the thread will move further, like the liquid will rise more. So it will be more sensitive or considerable change in length for a small change in temperature. And increasing the volume of the liquid in the filled the sensitivity will also increase. And how it affects the sensitivity? And increasing the volume, increase the sensitivity. Yeah, small change in temperature will cause a more liquid to expand. Greater amount of liquid is there. So increase sensitivity because of greater expansion. The first one, I cannot write greater expansion because when I'm using a thin capillary or I'm using a thick capillary, both have the same expansion because I did not change the amount of the liquid. But what happened, because this is having a greater area, large area, so small change in the liquid column. But for the other one, because we have small area, so greater change of liquid, but both have the same change in volume. So if you mention greater expansion for the first part, then you will lose the mark, the second mark, because expansion is same for both liquid. Like if I say this liquid have 2 centimeter cube expansion, the other is also having 2 centimeter cube expansion, but due to different areas, the height change in height is different. But in this one, when you use a large bulb, will have more volume, that will have a greater expansion. Figure 5.1 shows some apparatus designed to compare the ability of the two surfaces to absorb infrared radiation. This surface is a shiny, and on the left hand side we have dull black. The container, which are identical, are painted from outside. One is dull black, another one is shiny, and both are filled with water. So it means there is a water inside these containers. So both are filled with water and initially same temperature. Like example, if water here at 20 degrees centigrade, in the other container also 20. Describe how would you use the apparatus to compare the ability of the two surfaces to absorb infrared radiation. So how you can compare which one is a good absorber, which one is a poor absorber? We want to compare which one is a surface is a absorber, good absorber or poor absorber of infrared radiation. So what we can do? Yeah, black will absorb greater amount of energy, but the thing is practically how we can compare them. So what we will do, we will supply heat, because describe how would you use the apparatus to compare, like using this apparatus, how I can compare them, which is a good absorber and which one is a poor absorber of radiation. So I will heat both container for the same time and record temperature change so that we can compare which one is a. Yes, so radiation use heat source or same type of heat. Here we already have this heat source or a burner. So use heat from the burner and record the temperature change for both containers. State the result that you would expect. Like what you expect, like which one show a greater change in temperature? What do you expect? Which one will show a greater change in temperature? So the dull and the dark surface, the painted dark surface will show a greater change in temperature. The next part, a thermometer have a high sensitivity and linear scale. What is meant by high sensitivity? What's the meaning of a thermometer to have a high sensitivity? So greater change of a liquid for every liquid thread for every 1 degree change in temperature. That's called high sensitivity. And why a high sensitivity is important? Because here the temperature change will be small. Whenever you have a small change in temperature, high sensitive thermometers are important. What is meant by a linear scale? What's the meaning of a thermometer to have a linear scale? So when thermometer equal marking is there, so equal distances expanded by a liquid for each for every 1 degree change in temperature, that we called a linear scale. Or equal markings are there, that also you can mention. Or distance between each degree on the scale is same. A simple definition you can mention a distance between equal marking for every 1 degree change in temperature. Four identical metal plates at the same temperature are laid side by side on the ground and the rays from the sun falls on the plate. State which plate has a faster rising temperature when the sunlight first fall on the plate. Which one you think shows a faster rising temperature? The matte black, because dull and dark surfaces are good absorbers, so when it will absorb energy, it will show a greater change in the. There are two surfaces, one is matte black, one is shiny black. Shiny and matte here refers to like dull, and shiny refers to smooth polished surfaces there. So you can have a shiny black, you can have a matte black. So matte black is a good absorber as compared to shiny black. The apparatus shown, this is also known as a differential air thermometer. It is having two bulbs and there are air particles inside. Here also there is the air. The heater is switched off and this T is open so that air moves both sides and the levels are same. Now this T is closed, the tap T is closed, the heater is switched on. On the figure, mark clearly where the two liquid level might be after a short time. Look what happened, the heater will supply heat energy and we know dull and dark surfaces are good absorber as compared to shiny surface. So which side the gas will expand more? Inside a dull black or inside a shiny bulb? The glass bulb painted with a matte black or glass bulb which is having a shiny surface. So the dull black, inside a dull black, what happened? The air absorb more energy. If air absorb more energy, as we know, what is the effect of the heat? When we supply heat energy, the volume increases. So here, the heat energy absorbed by air, so volume of air increase, air expands. So as the air expand, air will push this level down, push the liquid level down. So what will be the new levels? So the level on the right hand side, on the left hand side will be lower, and the level of the liquid on the right hand side will be higher. The reason is that because the air, dull and dark surfaces are good absorbers, so air which is present in a glass bulb will absorb energy and it expand. That's why it push the liquid down. So one side the level will move down and the other side the level will rise, because this is exerting pressure but less pressure as compared to left hand side. So on the left hand side it will be lower and on the right hand side it will be higher. Yeah, basically what happened, the as increasing a temperature, it's pushing, the gas molecules are colliding, hitting the surface much harder and pushing the level of the liquid downwards. Is it clear? Differential thermometer, Leslie differential thermometer, air thermometer. And the explanation already I explained to you, the same part. Figure 4.1 shows a cross section of a double walled glass vacuum flask containing a hot liquid. So there's a hot liquid inside, the vacuum is there, and the shiny surfaces are there. The surface of the two glass wall of a flask have a shiny silver coating. Why the rate of heat loss through the wall by flask? Why the rate of loss of thermal energy through the walls of the flask by conduction is very low? What is the reason why there is no conduction? So due to vacuum, you can also mention because there is no medium, or you can also mention glass is also is a poor conductor. That's why vacuum or a gap between the walls. So there are no molecules, particle. That's why it does not conduct heat energy by conduction. but it is also acceptable, you can also say, because glass is also an like not a good conductor, that's also reduce the heat energy by conduction. So no particles between the walls. So reduce or no conduction, or reduce the heat loss by conduction. Why the rate of loss of thermal energy through the wall of the flask by radiation is very low? What's the reason why this, like it's not able to allow the to transfer the heat energy? Yes, what's the reason why I say low? Why not zero? Because vacuum is there, but practically there's no perfect vacuum. Like still, we are saying it's a vacuum, but practically, what happened? Not a perfect vacuum. That's why still it is losing the heat energy. But if it was a perfect vacuum, like nothing is there between them, then you can mention. But actually, what is happening? If you see, for example, this part of a flask, this is one piece glass. So if it's a one piece glass and between it it's a vacuum, so heat energy can travel to outside by a glass. But the thing is, because glass is not a good conductor, that's why it minimizes heat energy. If it's a perfect vacuum, then there will be no energy transfer by conduction because of vacuum, but still there is a glass, and glass is it's a one piece glass, so that glass is transferring energy and that energy can escape. And the second reason why radiation, because the shiny surfaces are good reflector, so does not prevent heat energy loss by radiation. Suggest with a reason what must be added to the flask in order to keep a liquid hot. If you want to keep this liquid hot for a longer period of a time, what we should add to this flask? So we should close this, because still what happened, due to convection and evaporation, the molecule can escape and this liquid will cool down. So what we should do to prevent the heat loss, so we should put a lid here, a cap or a lid. What this cap or a lid will do, it will prevent evaporation and convection. So close it with a lid or use a lid which prevent the heat loss by evaporation or convection. Or you can also mention prevent the hot vapors to escape. One side of a copper sheet is highly polished and the other side is painted matte black. The copper sheet is very hot and placed in a vertical position, as it you can see. The student places her hand at equal distance from the sheet. Explain why her hands are not heated by convection. Why her hands are not heated by convection? She placed her hand next to the copper sheet. What's the reason? Because what happened, the hot air, the warm air, it always rise up. It does not move sideways. So when the air which is in contact with the, yeah, that's the right answer. Hot air molecules rise up or convection happen on upward, because basically the convection is a movement of the molecule due to difference in the density. So when the air will become hot near the plate, the hot air will have a greater volume, so having small density, so it will always rise up. It does not move sideways. Why her hands are not heated by conduction? What's the reason why conduction is not taking place here? The person hand are, and air is also a bad conductor, that's right. For example, if any, because air is present, air is not a good conductor. Air does not allow heat energy to transfer, and hands are not directly in contact with the surface. So you can mention air between the hands and the plate, and which is a poor conductor, does not conduct. So air is a good insulator. State and explain which hand gets hotter. Which hand gets hotter? Right side is on the polished one and the matte black is on the left. Yeah, because dull and dark surfaces are good absorber and good emitter of heat radiation. So it will give out more energy as compared to shiny surface. So the left hand will become hotter. The reason will be because the dull and the dark surfaces are good absorber and good emitter. Equal volume of a gas held at a constant pressure. A liquid and a solid undergo a same temperature rise. Which these three, solid, liquid or gas, expands the most? Which one expands the most? Solid, liquid or gas? Equal volumes are there and at constant pressure. So expands the most gas and expand the least solid. The question is why the pressure of the gas must be kept constant for this comparison. Why we should keep the pressure constant? So what's the reason? The reason is because the volume of the gas is affected by pressure as well. The change in pressure can also cause a change in volume, or gases can be. Yes, so as changing in the pressure masks the effect of the increase in volume. Already in the question they mention it for a. So what is the reason for that? You will mention because the volume of the gas, what we are doing, we are finding effect of temperature on volume of the substance. But if pressure is not kept constant, then pressure can also affect the volume. So volume of the gas can also be affected by pressure. That is why it must be kept constant. Why 2 marks are there? 1 mark is for this part and 1 is for what you will write here. Okay, figure 5.1 shows an alcohol thermometer. There's alcohol inside the bulb. State 2 properties of alcohol which make it suitable for use in a thermometer. Why we prefer or why we use alcohol in a thermometer? Expands equally or linearly? So the answer here, number 1, because it expands linearly. That's one thing. Expand linearly means like uniform expansion is there. So you have like equal distribution or the marking on the thermometer. Second thing, because we want this substance which we are using inside the bulb in a liquid state, so it remain liquid for a greater range of temperature. So it remain liquid for a greater range of temperature. Or you can also mention expands more, or high expansivity, or high expansion, low specific heat capacity you can also mention, and low freezing point you can also mention about this. Two changes to a design of a thermometer which will make it more sensitive. You want to increase the sensitivity, what you should do? If you want to increase the sensitivity of this thermometer, increase the volume of bulb, that's right, or use a thin capillary. Larger bulb, more liquid, or thin capillary. Why it is an advantage for a glass surrounding of alcohol to be very thin? What's the reason why it will be advantage if we use a thin glass bulb? So it will be, if you use a thin glass bulb, it will be responsive. So increase the responsiveness, or it will show a temperature change in a short time.